Hello and welcome to the video of the activity called Slamina. This is going to be one of those activity videos where I just go through the activity step by step and make the program and explain why I do things the way that I do them. And you can either do the whole activity on your own, in which case, pause this video now, or you can go step by step with me and kind of pause, you try and do it, and then you can see what I did. You can compare notes with my thoughts on how to do it. But that's it, so let's just get going on the Slamina activity. By the way, Slamina is animals backwards. It's a little hint about what the activity actually is. So over here in the browser, I've got the activity up, and the point of the activity is really just to use responsive voice, which is voice synthesis, and anyang, which is voice recognition, just to use them in a kind of integrated project rather than just kind of doing little example things. And the idea behind this project is going to be that the computer with responsive voice will say the name of an animal backwards, which will make it hard to figure out. And then the user will have to say, using their voice, what they think the animal is. I think it is caribou or whatever. And if they get it right, then their guess is going to be displayed in green to show them that they were right. And if they're wrong, it will be in red to show them that they were wrong. So minimal feedback, just to keep this thing kind of small and tidy. Okay, so that's what we want. As always, before we start any project, we need to take some basic steps to get a project framework in place. So we should download the template project, unzip it, rename it to the name of the activity, which is Slamina, and put it in our activities folder, and then commit the changes to the repository and open it and begin. So let's do those steps. As I often do, I've actually just got a copy of the template P5 project folder here in my Cat263 repository. So instead of downloading the zip, unzipping it, I've just got it right here every time. So I'm actually just going to copy that into the activities folder now. And I'm going to rename it to Slamina. And that way I've got my template project with the correct name in the correct location fairly easily. I'm also going to open it with Atom. Drag it down to the Atom window over here. So now it's open and everything's all ready. Now, the other thing I'm going to do in this activity video, for those of you who are interested, is that normally when I commit things, I commit them using GitHub Desktop, right? So I run GitHub Desktop like so. And we see in the changes bar over here all of the files that changed when I added the Slamina folder, just like normal. And I would normally write a message down here in the message area, and I would click on commit to commit, and then I would click on the push button that would appear up here. But for today, what I'm going to do is I'm not going to use GitHub Desktop. So I'm actually going to quit GitHub Desktop. And instead what I'm going to do is I'm going to use Git from within Atom. So I'm going to open the index.html, and I'm just, before I do anything, I'm going to replace the title here, because I want, when my programs run in the browser, I don't want them to say, change this title in index.html. I don't want them to say template P5 project. I want them to have the name of the program. So the name is Slamina, right? Now, Atom knows about Git, and the reason that we know this is that Atom has noticed that all of these files are new. That's why they're green, right? They're green here because they're brand new to the repository that they're inside. And what I can do, if I want to commit them, is I can actually go down here to the Git menu at the bottom right. If I click on that, it's going to ask me who I am, just like GitHub Desktop does. And it's going to identify the repository that I'm using up here, Cat263. And I'm going to click Continue. And then I've got the same kind of interface that I have in GitHub Desktop, it's just that it's inside Atom, right? So here we have a list of all of the things that have changed. Again, same list of files. It's all of the things inside the Slamina folder. The only difference is instead of, I guess, it just saying changed files or whatever it says in GitHub Desktop, it's called unstaged changes. So there's an extra step that I have to take when I want to commit something in Atom, which is that I have to stage the changes. Generally speaking, I want to commit everything that I've changed, so I will almost always, I'm going to be clicking the Stage All button here. And what that's doing is saying, yes, I want to commit all of these changes to my repository. So now they all move down into the Staged Changes area, and that means that they're ready to commit. And to commit, I fill in my little message here, started Slamina activity. And that's just the same as in GitHub Desktop, right, where you write your message, and then just like in GitHub Desktop, I click on the commit button. Click, and in it goes. So now it's committed, so it's in my local repository, and you can see the history down here, in fact. You can see the history of this repository, and you can see that commit that I just made, started Slamina activity. If I want to push it up to github.com, then you'll see next to this GitHub button here is a button that says push 1, and that's saying, again, just like in GitHub Desktop, that I can push these changes to the remote repository on github.com. Functions in exactly the same way. So if I click that, and it says pushing, and the little arrow jumps up and down, or just jumps up actually over and over again, and now it's done. And so that was the same thing, right? I've committed these changes to my local repository, and I have sent them up to github.com remotely. Exactly the same thing, it's just it's in the comfort of Atom, so I don't have to switch to another application. That's how I actually do things when I'm developing, so I just wanted you to kind of see what that looks like. So that's a little aside. Okay, so we're ready, right? We've done the project creation thing, we've got the template, we've renamed it and put it in the correct folder, and we've got it open in Atom, so we're good to go. So how are we going to implement this thing where the computer says an animal name backwards and the user guesses it with their voice? So there's a few things that we need to do, and they correspond to basically a plan that we can execute in order to make this happen. So I'm just going to look at this plan actually, because it's really a restatement here of this paragraph. So the first thing I'm going to need is I need a list of animal names, because otherwise there's nothing to guess from, right? I need to be able to choose a random animal, and to be able to do that, I need the data of animal names to choose from. I'm then going to need to be able to choose a random animal from my list of animal names, and I need the computer to say it backwards, because that's how we're going to give the user their prompt to make a guess. So I need to figure out how to choose a random animal and say it backwards. Then I need to use Anyang and set it up so that it listens to the user when they say what their guess is. And finally, I need to display on the canvas, was that guess right or wrong? Which, as I said, I'm going to do by displaying what Anyang heard the user say, and I'll make it green if it was right and red if it wasn't right. So it's fairly simple, but you know, it's a nice integrated kind of a program. So let's begin. Number 1, animal names. Now this is a common thing that we find that we need when doing programming projects. With projects like this, where we've got some kind of data-driven effect, right? We're using the fact that we want a lot of animal names to choose randomly from to kind of drive the program. A thing that we then need is nicely formatted data in the form of animal names that we can put into our program, so that we don't have to, you know, go to Wikipedia and search for common animals and then laboriously type them into an array in our program, for example, right? We could do that, but that would be frustrating, and we would like to avoid it. And luckily for us, there's lots of data online in various forms. And very luckily for us, this developer called Darius Kazemi, who is wonderful, and you should look up his work in general. He does a lot of work with Twitter bots, especially. He has this GitHub repository called Corpora, and that contains all kinds of lists of stuff, basically. Interesting lists of things. And one of those lists that he's got is a list of common animals, and that's what we're going to use. So the first thing we're going to do is we're going to go to that list. So I'm going to open up this link, and this is what it looks like. Now you can see that the type of file here is called common.json or JSON. That is a data format that people use in JavaScript. It's something that we will talk about further. You may have already encountered it. Importantly, just for now, if we look at the file, which is this stuff here, we can see that it's got an array in it, right? So it's got this thing that says animals. We can kind of tell that this is the property of an object, right? Because it's got the colon after it. And then inside that animals thing is an array. So there's square bracket, and then there's just this long list of animal names in alphabetical order as it happens. quite a long list, not too long, but it's pretty long. And then there's the closing square bracket here, right? Wonderful. So this is the list of animals that we're going to use. It's already in an array. It's all set up for us to work with. We don't have to do the extra work to create this data set. So I'm going to copy this list that I've just selected, and I'm going to copy the array part, right? So just the stuff that's inside the square brackets and the square brackets themselves. So I'm using Command C. You would use Control C on Windows. Please learn those keyboard shortcuts if you have not already. So we've gone to that file, we've copied the array, and now in our program we're going to declare a constant called animals in the script, and we're going to put that array inside that constant. And that will mean that that data is inside our program. So let's go over to the script. I don't really need the index.html open for now. And we're not going to use preload. And indeed, just for clarity, I'm going to delete this extra commenty stuff. It's poor style, but it's just so that it's a little bit easier to have more stuff on the screen. So I'm going to declare a constant, const, called animals. That's the name of the constant. And I'm going to assign what? The array. So I'm going to paste it in with Command V, or that would be Control V if you are on Windows. And I'm going to put a semicolon at the end because that's good. And then I save. And now that list is inside an array inside my program. So I've got the data, right? The data is there, ready to be used. I've got this nice list of animal names. So what's next? Well, now we can use those animal names for our guessing game. So let's do that. Step 2, choose an animal and say it backwards. This is really the core thing that we're doing in the program. This is the thing that drives the user's behavior. We want the computer to choose a random animal and say it backwards. And the point of this is that if you say something backwards, it can be hard to figure out what it was, and therefore it becomes an interesting guessing game. So we need to be able to choose a random animal, and then we need to use responsive voice to say it, but we need to reverse it before we say it, okay? Also, given that in general in a browser you want to trigger audio from some kind of user interaction, we're going to trigger responsive voice when the user clicks on the screen, just to make sure that that works. Also, because it is actually slightly complicated to reverse a string in JavaScript, it's a little surprising that there's not just a function to do it, but there is not. So I'll provide the function for doing that. So let's do what we need to do to say this animal backwards. The first thing that we're going to need to do is we need to keep track of what animal it is that we're supposed to be guessing in the program. And obviously that should start out empty because we haven't chosen which animal it is, but we will need to remember it so that we can check if the user is right. So we're going to have a variable called current animal, and that's going to be the animal that the user is meant to guess. And we're going to start it as an empty string. So let's add that variable to our program. I'm going to add it after my big array. So let current animal is assigned empty. So there's nothing in there right now. There will be once we've chosen a random animal, right? But we know that we're going to need this, so we put this in first. The second part of this is that we need to be able to reverse a string of text in order for this program to work. And as I said, it's a slightly complicated thing. So rather than try and force you to do all of the research necessary, I've just got the function literally listed here in the activity. So put this function into the program. I'm going to copy it, Command C, and I'm going to paste it in at the bottom after draw. Paste. Okay, so let's have a quick look at this, just because it's worth understanding. So the function is called reverse string. It's not called reverse animal name, for example. And the reason for that is that if we're going to write a function that does just reverse a string, we may as well make it as generic as possible so that we could potentially use it for all kinds of stuff. So that's why it's reverse string, not reverse animal, for example. So reverse string has a single parameter, which is the string of text that we're going to reverse, called string. And we have to perform 3 steps to get this string to go backwards. The first thing is that we're going to use a method, a string method called split. And what split is used for is that you call it on a string, so string.split, and you tell it, what it does is it breaks the string apart according to some principle of division. If you tell split that you want to break the string apart based on nothing. So this is an empty string, right? This is not a space. There's nothing in between these quote marks. What you're telling it is separate every single character from every other character and put them all into an array. So what we're going to end up with is an array with each character from the string in separate elements. So it's been broken out into an array. That's what split does. We're saving that into a variable called characters. Then we have the good fortune that you can reverse an array, which is what we wanted to do with our string, right? So once we've got an array called characters, we can just call the reverse method on it, and that will flip the order of all of the elements. That's why we converted the string into an array, because we wanted to be able to use the reverse method of the array. So reverse characters ends up with an array with that string in it, but all of the elements are back to front. Then we want to be able to turn it back into a string, and so we use the kind of counterpart of split, which is a method called join, which can join together all of the things in an array and turn it into a string. Again, we're going to join it together. The thing that we're going to put in between each character in the array when we join it into a string is nothing, because we want them all to just be joined to each other. If I wanted a space, or like if I wanted a hyphen between every character in the array, I would put a hyphen in here. But because I want them all just to be joined together normally, I put an empty string. Finally, because this is a useful function, it returns the result of that join. And so what we get is a string that is the reverse of the string that came in. So quite a lot going on there. That's why I didn't want to kind of struggle through working it out from first principles. This is the kind of example you would probably find on Stack Exchange, for example. Okay, so we've got our reverse string. Now we can actually get responsive voice to say a reversed animal. So this is where all of the things kind of come together. We've done sort of some legwork, right? We've got the big array of animals. We've got a variable to keep track of which animal the user is meant to be guessing. And we've got our special function that reverses strings. Now we're in a position to say a backwards animal name. So as I said, we want to do that in a mouse pressed function. So let's define a mouse pressed. I'm going to do that above the reverse string, just because it sort of feels more part of the interactive component of my program, and because it's going to use reverse string. So function mouse pressed. As we know, this is called by P5 automatically when the mouse gets clicked. What are we going to do inside this mouse pressed function? First of all, we're going to get a random animal name from the animals array, and we're going to put it into the current animal. And we should remember that we can do this most easily with the random function from P5. So we're going to assign to current animal, because that's where I want to end up with a random animal. And we're going to assign it using random. We're going to get a random value from that animals array, which is this one up here, right? The one with all of the animal names in it. So we're going to get a random thing. Could be buffalo, could be coyote, could be minor bird. Who knows? So we're going to put that into the current animal variable, and that way we're going to know what the user is meant to guess. And then we want to say this backwards, right? So what are we going to do? Declare a variable called reverse animal and assign the reverse of current animal using that reverse string function. Kind of a bit hand-holdy there, but you know, it's okay to have your hand held occasionally. So I want a new variable, so I'm going to say let. It's going to be called reverse animal, because it's going to be the reverse of the animal. And I'm going to assign it the result of calling my reverse string function. So I'm going to call reverse string, and we know that that can reverse whatever string you give it. What do I want to reverse? I want to reverse whichever animal was chosen and put into current animal. So that's going to send the current animal, let's say it's chinchilla. So we do random animals, chinchilla comes out of here, goes into current animal, then we're going to send current animal into reverse string, so that's going to send chinchilla. That's going to arrive here as the string it's supposed to reverse. It's going to do all of its magical things until chinchilla is backwards. I couldn't possibly imagine what that would sound like. That's going to come back as a result, the reversed string, and then that is going to come and end up in reverse animal. So by the end of that little series of operations, we've got the reversed animal in this variable, the reverse of chinchilla in my example. Finally, I'm going to use responsive voice to say this reversed animal name, and this is sort of where the magic happens. Now, if we don't remember how to use responsive voice to say something, we should go and look at the API. So I'm going to go to responsivevoice.org/API to remind myself, just in case I've forgotten. So I go to the API. I happen to know that this is the URL for the API. I could also find it by just going to...
Welcome to
oh dear
Responsive
God,
Voice.
I shouldn't have
Voice
done that.
enable your website or app in minutes.
Yeah, thanks. This is one of the more obnoxious things actually about this website, is it tries to say things all the time. You're probably familiar with that. So I'm coming to the API just to make sure I know how to use the speak method here. And the easiest way really is to just quickly look down here at the example. I'm just going to use the simplest example, right? So I write responsive voice. I notice the capitalization of the V here, dot speak, and then the thing I want to say. Here it's something in quotation marks because they're directly writing the string in. I'm going to be speaking the reverse animal variable. Okay, so that reminds me of what I'm supposed to type. So let me type it in. Responsive voice. That's the name of the library as represented by this object, this variable in the program, dot speak. And then I'm wanting it to say whichever animal is inside the reverse animal variable. That was chinchilla in my example, but it could be anything, right? And that is it, right? So basically, if I click, when this program is running, it gets a random animal. Let's say that it's rat. That's easier to think of the reverse of. So rat comes out of here and ends up in current animal. We send that into reverse string, which processes it and sends it back as what? As TAR, which is the reverse of rat. That ends up in here. And then we say responsive voice, say the word TAR, which is tar. So we would expect responsive voice to then say tar. That's what we wanted. Let's go back to, I'm just going to close a couple of windows here. Yeah, so we're done. So when the program starts, if the user clicks, they will hear the name of a random animal backwards. So this is really the first point where our program might do something. So let us run it with Atom Live Server. Don't see anything, right? Because there's no interface. This is all voice-based. So I'm going to click now. Oh, well, this is interesting. I've forgotten to do something. I will put, oh my God. I'll put the instructions for what I have forgotten to do into the activity for those of you who are doing it without me. And for those of you who have made it this far, can you figure out what silly thing I have omitted when I was trying to do this? Perhaps you can. The thing that I don't have is I have not included the responsive voice library. Very foolish, but also like a super common thing that can happen. So I'm not gonna be too embarrassed about this. The thing that I've forgotten, and this really only came up because this is the moment when I needed responsive voice, right? This is the first time I tried to use it. I don't actually have it. If we go and look in my index.html, I have P5 and I have P5 sound, not that I'm using it, and I have my script. I do not have responsive voice, so I need to go and get responsive voice, or I'm not going to be able to use it. So let me head back to responsive voice API. And let me make the possibly terrible mistake. Oh, maybe I can click copy here. Okay, so I'm going to copy it. And now I'm going to paste it in. Oh, that didn't work. Okay, I'm just going to select it. Let's not
less than script src equals
that was what I was afraid of.
https://code.responsivevoice.org path /responsive evoice.js ? Key equals your _ unique _ key single quote less than script greater than.
Great. So I'm going to paste that in. Don't get a responsive voice to read JavaScript, or HTML. So I'm going to paste this in. Now, there's a little secret that I will use at this point just so that I don't need to show you my API key. Not because that's a big problem, but just because, it's sort of, as I've said before, it's professional. It's better if you don't see my unique key. Just for now, I could use my key here, but instead I'm just going to delete all of the key stuff altogether, including the question mark. This will actually allow me to use responsive voice. It's a little bit cheeky, because they want you to have an API key so they can track usage, but it will still actually let me use responsive voice. When you are using it, please use your API key. It's a good thing to practice, and I do as well when I'm using it. But just for this example, I'm just going to have the link to the library without the API key. So that was the big mistake that I made. I'll be sure to include that properly in the instructions when I am finished with this example. So let's head back. Slamina. I click.
Flow.
It says flow, which is interesting. Actually, this is not something I had thought of, but what animal is that backwards? Flow, F-L-O-W, is wolf, right? So wolf is flow backwards. So when I click, it picked a random animal, which was wolf. It reversed the text so that it said flow, and then it said it with responsive voice. So it works. And actually, it'll say a new animal every time I click, right?
Ragwalk.
Ragwalk.
DAOT.
D-A-O-T. That's toad, right? It couldn't work out how to say it.
Amel.
Amel.
Tuxum.
Tuxum, and so on. So it's working, right? We've got that step working. Wonderful. It's already kind of entertaining. So the big other component of this is making Anyang do voice recognition so that I can say what animal I think it is, and Anyang will hear that and we'll be able to know what's going on, right? So let's set up Anyang first. So setting up Anyang is kind of like, it's the same every time. There's kind of like a little skeleton, and you may end up memorizing it, or you may end up going to the Anyang API or the Anyang homepage to find that kind of default setup. I'm going to do it step by step here. So we're going to write an if statement that checks if Anyang is available. That's the first step. So in our script, where are we going to do this? We're going to do it in setup, because generally speaking, when we want to use Anyang, we're going to want it to sort of run at the beginning of our program. It's going to start listening. So let's head here. So if Anyang, that's the way that we check if Anyang is available in this browser. Anyang is the object that contains the speech recognition stuff. If that stuff didn't work with the browser, this would be, I would have to take a guess and say it would be undefined, in which case this if statement would fail. So that way we can be sure that if this if statement succeeds, it means that Anyang and speech recognition is available. Okay, in it, we're going to create a classic commands variable that we use with Anyang. It doesn't have to be called commands, that's just their convention. And we're going to create a command that is, I think it is, oh, and I've written this wrong as well, I'll correct that. I think it is animal. And we're going to use their splat to do this, the asterisk and then a variable name. So what that means is the user can say anything they want here, and Anyang will remember it. Okay? And what that command is going to do is it's going to call a function that we're going to call guessAnimal. Yeah, okay, that's right. Sorry, a bit of dead air there. I was just making sure I knew what I was talking about. So let's take that step. So I need a commands object, so I'm going to say commands, even though I know there's only one command. Whatever, they do that as well. And that's going to be a JavaScript object, literal, the thing inside the curly brackets. Then we know that the property is going to be the name of the command. And I'm going to put it in single quotes just because that's their convention. And I'm going to say, I think it is, it is. And then instead of writing, something specific like rat, which would be pointless, I'm going to put this splat thing that they say, which is an asterisk, and a variable name, animal. So what I'm saying is they're going to say, I think it is, and then something else. They're going to say more stuff. Maybe it's going to be wolf, maybe it's going to be jackalope, maybe it's going to be Tina Turner. We do not know what they're going to say, and that's the beauty of it. So that's my command. Then we have a colon, because that was the property name as the command. And then we have the function that should be called when Anyang hears something that matches this. And that's going to be called, what? GuessAnimal, right? GuessAnimal. A named function. We could do this with an anonymous function. I think it's nicer to do this with a named function. So if it hears this, it's going to call guessAnimal. Perfect. Then we're going to follow the other two kind of classic Anyang-y things. We're going to use add commands and we're going to use start. Again, this is very much part of just an Anyang template. So Anyang.add commands, and we give it the variable that we just created with the command in it. And Anyang.start allows us to start speech recognition. Those are the extra two things we always do. Since we're going to be displaying text a little later on, we could also, and perhaps should also, just set up some default text style stuff in setup. So I'll do that too. I'm going to continue doing this inside the Anyang if statement, just because if this is false, nothing matters, and we may as well go cry in a corner, right? So I'm going to set text size to 32, and I'm going to set text style to bold, just because that feels good, and I'm going to set text align to center, just because that feels like that will be the easiest way to make it look roughly okay. I believe I can set it to, maybe I can set it to center actually, so that it aligns both vertically and horizontally to a position. Okay. Now Now we're ready to handle the case in which the user actually says something. So there's two parts to this. One is that we need to be able to remember what they guessed. And I'm going to say that that's a variable called current answer, and it's going to start out as an empty string because they haven't guessed when the program starts. So we need that variable to track what it is that they said most recently, in particular, so that we can display it. So that should be up here with our other main global variables and global constant. Let current answer, you could write guess, and that's going to be an empty string as well. So that's what we'll use to be able to display their answer on the screen later on. Then we also want this guess animal function that we said we were going to have, right? So we can define it wherever we want. I'm going to define it underneath mouse pressed. So it's going to be a function called guess animal, and it's going to take a single parameter, which I'm going to call animal, because remember that when Anyang calls this, it's going to send what the user said to the function as a parameter. It's going to be a string that contains whatever it is that the user said. So let's define that function. And we're going to do that down here, as I said. So function guess animal, bit of a typo. The parameter I'm going to call animal. It doesn't have to be called animal. I could say that it's like guess if I wanted to as well. Importantly, this parameter name here does not have to match the thing that I put in the command. This is just a courtesy thing, right? It's just you call it something that makes sense so that it's easy to read when you're reading your code. Making them correspond is maybe a good idea anyway though, right? So we'll call it animal down here as well. So when Anyang hears, I think it is rat or whatever, it's going to call guess animal and it's going to pass the word rat into this parameter here so that we can then deal with it as the user's guess. So that's our function definition. Inside that function, we don't need to do too much. We just need to assign the guess that's inside the animal parameter into the current answer because it is the current answer at this point. So we've heard them say animal, so we want to say that the current answer is whatever the animal is that they just said. That's useful, so now we can remember what they said. And then just to be able to check whether this is working or not, we're going to print out what their answer was in the console, just so we can get some immediate gratification. So console.log current answer. That way we'll know what they said, which can be fun as well, just to see what Anyang thinks that you said. So now, at least in theory, if we run this program, we expect Anyang to work because we set it up here in setup, and we expect to be able to say, I think it is, and then the name of an animal, or frankly anything, and we should see that pop up in the console. So let's see if that's true. So I need to bring up my JavaScript console. I like to do that with a keyboard command. Here you can see actually, by the way, oh my god. So you can probably see from the error messages I've forgotten to do something else. Classic, and again, like, you know, I could claim that this is just-in-time programming, but really it's just that I'm forgetting to do stuff. I don't have Anyang, because similarly I forgot to download Anyang and put it into my index.html. You can also see, by the way, just here that responsive voice is complaining about not having an API key. It's sort of like, it's not a polite thing to do. It's still working, because we can still hear the voice, but it's not nice. We should be using an API key. I'm just not using it for this example. So this error here is telling me, hey idiot, there's no such thing as Anyang, and we know immediately it's because I never included Anyang. So similar to last time, I need to go to the Teleter website where Anyang lives, here, and I'm just going to go and quickly grab the script tag that they have here to the library. So there it is there. That's their nice script tag. I'm going to copy it with Command C. I'm going to close that window. And I'm going to go over to index.html and I'm going to paste it in after responsive voice here and save. And I'm going to tab it in because I feel weird. Okay, so forgot to include both libraries until I suddenly realized that they weren't there due to error messages. That's a bit embarrassing, but this happens to the best of us and the worst of us. And I'm probably somewhere around the worst of us. Okay. So having done that, we no longer have the Anyang error over here because we included it. So I should now be able to click here an animal and then say, I think it is, etc.
Rate nap.
I think it is panther. And there you go, right? So you can see down here in the console, right here, that the word panther popped up because that's what Anyang heard me say. I think it is Pippin is great. And, you know, that's the way that you can make yourself feel good if you're having a bad day. You can see Pippin is great in your console. Anyway, we can see that this is working, right? So it's hearing what I'm saying. So the magic is working. We just have a last little bit that we need to do. So we need to display whether or not the guess is correct. And we need some sort of it feels like we need some kind of visual recognition of what's going on. So in Draw, let's create that. So we'll set a background color, just because that's always a sensible thing to have. So in Draw, which is just here, I'm going to set the background to black, because I like black backgrounds. I am going to also need to create a canvas, which I haven't done. Otherwise, it's going to be 100 by 100. So that's embarrassing again, but makes sense. And again, I'm only noticing it now because now I need a canvas to draw things on. Previously, I didn't. I'm going to make it, I'll just make it window width by window height. That's easy enough. That's just using the built-in P5 variables, window width and window height, that know how big my window is. Back to Draw. Then I'm wanting to display the current answer, and like I said right at the beginning, what I want to do is I'll display the answer in green if it's right and red if it's wrong. So how do I know if the current answer is correct or not? Well, I know what the current answer is, and I know what the current animal is, like what they were supposed to be guessing, so I can check if they're equal to one another, right? So I can say if current answer, which is what the user just said, or has said, or will say, is the same as current animal, then that would mean that they had gotten it correct. If they've got it correct, I want to set the color of the text that I'm just about to display to green. So I'm going to say fill RGB, right? So 02550 is green. If it doesn't equal the current animal, then I'm going to say else. And I'm actually going to allow myself to potentially make a mistake here, but let's see what happens. If they get it wrong, I'm going to set it to red, right? So that's 25500. And then, as you might expect, I'm going to display the current answer variable on the text, on the canvas as text. So I'm going to use the text function, and I'm going to display current answer, which is what they said, and I'm going to display it at position width over 2, height over 2, which is just the center of the canvas. And there we go. Let's see what happens. There's one more thing I need to do, which I will again put into the steps of the activity. I'm feeling like I've made a few too many mistakes, but it's too late to go back now. And it's good for you to see me making mistakes. So let's see what we see here. So I'm going to click.
HSIF.
I think it is fish. So that worked, right? It displayed the word that it thought I said was fish, so it displayed it in green. Let's try and get it wrong on purpose.
Hey teach.
I have no idea what that is. I'm going to click again until I get something I know.
Rumal.
I think it is lemur.
Nubab.
I think it is baboon. Okay, so maybe we're not going to run into the problem. And it's quite a weird and specific problem. So it would be very understandable, and maybe it's good that I did things this way. This is a very understandable way to try and check whether the user got the answer right. But it is open to a particular kind of a flaw. And we actually saw when it wrote out panther what that flaw is. When I said panther, if you were watching, you saw in the console, I guess it's not there anymore, right? Because I've saved since then, unfortunately. It wrote it out with a capital P. And what that would mean is that if it was comparing it with a capital P to the way that panther is presumably written in here, it's got a lowercase p. And if we are checking those, they're not actually the same. Panther with a big P is not the same as panther with a little p when it comes to your program. And so it would actually say that we were wrong, which doesn't seem very fair because it's hard to specifically say panther with a lowercase p. So what we would actually want to do here is we want to convert the answer. Actually, let's not do it here. We'll do it here. when they guess. So here's the guess, right? Animal. We want to convert that to lowercase. And there's a function for strings, you may have used it before, called toLowercase that will take whatever is an animal. So if that was panther with a big P, it would convert it to panther with a lowercase p. So we're going to convert it, and then after we've converted it, we're going to put it into our answer. That way our answer is always going to be converted to lowercase, and we're much less likely to have situations where our guess is correct, but is said to be wrong because of capitalization. Actually, while I'm here, I'm going to delete this console.log because I don't need it anymore. So that really completes a working version of this program. As you saw, it was working. I found that little extra error that I just fixed then, but that wasn't really preventing it from working. So now we can do things like say, I think it is dog, and if it's right, it's green, and if it's wrong, it's red. So this works. It's a simple program, but I think quite a neat program, quite a fun one to have at our disposal. Remaining things to be done are, you could probably break this program down into a few more functions. It's a good idea to do that. You could even think, I'm just looking at this, like say animal backwards with an animal. You could even write just a say backwards function, right? That could say any word backwards. Maybe that would be a more, a sort of a nicer function to have, because it's more reusable, right? That you're much more likely to want to be able to say other stuff backwards than specifically animals. So that might be a better name for a function like that. But that really concludes it. There's lots and lots and lots of things that you could improve on and change in this program to make it different and more interesting than it is right now. There's a bunch of ideas that I've listed here in the activity, such as just some interface stuff to make it more easy to engage with for a user, more visual and sound effects perhaps. Maybe you want to turn it into something more competitive and have a counter for correct guesses. Maybe you don't want to use animals, you want to use something else like new technologies or something. There's lots and lots and lots of things that you can layer on top of this. Hopefully that feels like something that's got some potentially, sort of some exciting potential that you can use. So that's it for this activity video. I kind of apologize for screwing up a couple of times, but I'm human, and I also hope that shows you that it's very normal to make errors. I make them all the time. And that we just recover from them. We work out what's wrong and we fix it. That's just programming. Them's the breaks. Okay, that's the end of the activity. Hopefully you enjoyed it, and you're going to enjoy extending on the Slamina basic program into something much more exciting and funny. Bye for now.